Now let's deep dive into the first topic, which is integrated circuits. Integrated circuits are also known as ICs. So in previous chapters, we learned about basic components like resistance, capacitors, and everything. Using those components, you can make simple circuits and even complex circuits rather, but when you are making them by hand, they would generally be big in size and they are usually made for a specific purpose. Now, what companies did was they created these ICs, which were nothing else but those circuits packaged in a very small size for a specific purpose. Let's understand this using an example. So, you would have seen running lights that we use while decorating a house for festivals like Christmas, right? So, these running lights are having a specific circuit for this purpose that controls the lights. So what companies did was this was a very common use case, and they kind of created an IC for running lights only. Similarly, almost every modern appliance has ICs inside them. So let's see, how many appliances can you figure out around you? Maybe pause this video and try to figure out a few appliances around you. Done. So maybe you saw a laptop, a mobile phone, a TV, and maybe a microwave. So all these modern appliances have numerous ICs inside them for a specific purpose. Let's say we'll take example of mobile phone. So mobile phone, as you know, is also having some function to receive audio and send audio, right? Similarly, if it is a smartphone, then it would also have a function of receiving data over the internet from the internet, right? Now, these are different functions that a mobile phone is doing. So for each of this function, there are dedicated ICs inside that mobile phone. So the mobile phone that you're seeing has many different ICs embedded inside them, working in a symphony to create a modern appliances like a mobile phone. Okay, so every other gadget will have multiple functions to perform. So I'll not go into each and every appliance, but rather encourage you to sit and think what different functions do a gadget performs, and think of those functions. And probably there is an IC doing that particular function. So that is how ICs are almost everywhere around us. Now let's see what microcontrollers are. A microcontroller is a very small, low powered computer packaged as an IC. They have a processor, RAM, input output peripherals like GPIO pins. They usually operate at lower speeds, around 1 MHz to 200 MHz range, and need to be designed to consume less power because they are embedded inside other devices. You can program your microcontroller, and we'll learn it in this series. You can program your microcontroller using modern languages like C and Python, and it would start behaving like the brain of your circuit. You can take inputs from sensors, process them based on a logic, and actuate using the actuators. We learn all this in this series itself. Now let's see what sensors are. A sensor is a device that detects and responds to some type of input from the physical environment. The specific input could be light, heat, motion, moisture, pressure, or any one of the great number of other environmental phenomena. The output is generally in the form of signals that is sent to circuit for further processing. In our kit, we have provided a lot of sensors that we will be using to build projects throughout this series. There is one LDR, light dependent resistance. Its resistance changes based on the intensity of light that falls on it. There is an ultrasonic distance measurement sensor. There is a humidity and temperature measuring sensor. So we'll see how to use them in our projects. All the details about an electronic component is always available in the data sheets. Data sheets are basically the documentation of all the electronic components. If you Google the part number along with the word data sheet, then you will certainly find the PDF version of that data sheet online. On my screen, you can see the data sheet of light dependent resistor that you have in your kit. This data sheet tells us everything about that particular LDR, the electrical characteristics, the light source, and the intensity that you can expect. Also, the dimensions. These dimensions are very useful when you are giving it for manufacturing or the casing for that matter. These graphs tells us about how the resistance would change based on the intensity. It also tells us the maximum voltage and the current that you should provide to that LDR, and also all the aspect of that LDR in terms of sizing and everything. Typical applications also help us create circuits and tells us how can we utilize this LDR in various type of applications. So if you see overall, this data sheet tells us everything in and out about that LDR and how to use that in our circuit. Now let's see what actuators and output units are. Actuators are all those components which are used to make an impact in the physical environment. Like for example, motor. When you give power to the motor, it rotates and can, for example, create translation motion as well if you have wheels in attached to that motor. There are other output devices as well. Like for example, LEDs. LEDs stand for light emitting diodes. These are special kind of diodes that emit light when provided with the right voltage. There are a few LEDs already provided in your learner kit. Try and observe them. See what distinguishing features you find in them. Also, it would be a good idea if you search for their datasheet and try to figure out the operating voltage. This voltage range is the voltage that you have to provide to turn on this LED. Now let's move on to the last topic of our lesson, which is development boards and modules. Dev boards are generally made for learning purposes but can also be used in industrial applications. A development board is a printed circuit board containing a microprocessor and minimum support logic needed for a student to become acquainted with the microprocessor on the board and to learn to program it. Let's look at a few examples. Arduino Uno is a microcontroller board based on Atmega 328P. It has 14 digital input-output pins, of which 6 can be used as PWM outputs as well, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, and ICSP header, and a reset button. It contains everything needed to support the microcontroller. Simply connect to a computer with a USB cable or power it with AC to DC adapter to get started. Next example is Raspberry Pi. The Raspberry Pi is a low-cost credit card-sized computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It runs on Linux operating system. It is a capable little device that enables people of all ages to explore computing and to learn how to program in languages like Python. It is capable of doing everything you would expect a desktop computer to do, from browsing the internet and playing high definition videos to making spreadsheets and playing games. It has various connector options, like for example, it has GPIO pins, an audio jack, USB cable connector, Ethernet port, and newer versions also have HDMI ports. Next is ESP32 Node MCU Wi-Fi chip. It is very popular in IoT devices because it has Wi-Fi built in to the chip itself. They are ultra low power devices, also with Bluetooth connectivity, 34 programmable GPIO pins, 10 touch sensor pins, SPI, UART, and I2C type of tons of features. They can be very useful in your IoT projects at later stages. Similarly, there are many more Wi-Fi modules available in the market. Like for example, this very popular Node MCU ESP8266 chip based module. I hope by now you have fairly good understanding of all the fundamental building blocks of electronics. Next lesson is all about understanding Arduino board in detail. So see you there.